Welcome back, everyone. In this video, we will be discussing ratios and proportions. Ratios relate how much of one thing there is compared to another. Let's look at a simple example to see how this works. Take a look at these shapes here. If we want to make a ratio of the number of squares to the number of circles, there are two ways we can write it. First, let's go ahead and note we have 6 squares and 3 circles. So the numbers 6 and 3 represent how much of each shape there are. One way we can write ratios is by having a colon like this in between the two numbers representing what we are counting. We often read the colon as the word 2, so writing the ratio like this would be the number of squares to the number of circles. Using the numbers for this example, we would write that as 6 to 3, meaning there are 6 squares compared to the 3 circles. Now, just like fractions, ratios written like this can be simplified by dividing both numbers by a common factor. In this case, both numbers are divisible by 3. When we divide both numbers by 3, we get the simplified ratio 2 to 1. Keeping in mind that the number on the left represents the squares while the right represents the circles here, we can interpret this as for every one circle, there are 2 squares. In addition to using a colon, we can also write ratios as fractions. So if we want to write the ratio of the number of squares to the number of circles here, the number of squares would be our numerator, while the number of circles would be our denominator. Using the numbers we have in this example, we would get 6 over 3. And as you might expect, we can simplify this fraction by dividing by the common factor 3, giving us the simplified fraction 2 over 1. Which we can just think of as 2, which we can interpret as there being twice as many squares as there are circles. If you're still a little shaky on ratios, consider the common ratio that modern television and computer screens follow. You may have already seen this ratio, 16 to 9. This ratio measures the horizontal width of the screen compared to the vertical height. For all screens that follow this ratio, no matter how big or small this screen gets, when we make the ratio out of the physical dimensions of the width to the height, it will simplify down to this 16 to 9. Now that we have discussed the basics of ratios, let's talk about proportions. Proportions are equivalent ratios. That is, two ratios that are written as fractions that are equal to each other. For our TV or computer screen example, no matter what the width or the height of the screen is, it follows the ratio of 16 to 9. So no matter what our width and height is, these two ratios should be equal and thus can be written in a proportion. Hypothetically, there could be a TV screen with dimensions that were equal to 3 times each of these numbers in our ratio. We could have a TV screen that was 16 times 3, giving us 48 inches in width, and a height of 9 times 3, giving us 27 inches in height. We could then make a proportion out of these dimensions. We know the width is 48 inches, and the height is 27, so our ratio would look like this. And if it obeys the ratio 16 to 9, we can make the proportion equal to 16 over 9. Now the left side of this equation clearly reduces down to 16 over 9 by just dividing each of these numbers by 3. So we see that our proportion makes sense. Using proportions like this can be very useful when trying to determine how much of one thing there is should be, when you know how much of the other thing there is. Let's work through some examples to see how we can use proportions in problems. Consider a TV screen which has the width to height ratio 16:9, but has a height of 36 inches. Now we're trying to find what is the width. Since we know the ratio of the screen, we can make a proportion where the width over the height has to be the same as that ratio. So the ratio 16/9 has to be equal to whatever the width is divided by whatever the height is. In this case, we know that the height was 36 inches, but we don't know the width, so let's just leave that as a variable x. We now have an equation where we can solve for our unknown x. The easiest way to solve proportions is typically to use cross multiplication. That is, we multiply across the diagonal and equate the products. In this case, multiplying along this diagonal gives us 9 times x, while multiplying along this diagonal will give us 16 times 36, and these two products should be equal. Doing the multiplication, we get 9x equals 576. Then we can solve for x by dividing 9 on both sides, leaving us with x equals 64. And so by using proportions, we find that the width of this screen should be 64 inches, the same unit as our height. Another common scenario where proportions get used is in recipes. Let's say a recipe calls for 3 cups of an ingredient to serve 5 people. And the question asks us how many cups are needed to serve 14 people. Well, first off, we can make a ratio out of the cups to the number of people. There are 3 cups to the 5 people who can be served, or written as a fraction, we'll do cups over people, so 3/5. Now this right here, we can interpret as our proportion. The number of cups over the number of people should always be equal to the ratio 3/5. In this case, we're looking for the number of cups, so we'll leave that as our variable x, but we know we want to serve 14 people, so that will be the bottom of this ratio, and that should always be equal to, from the recipe, 3/5. Again, we can just do cross multiplication. That will give us 5 times x is equal to 14 times 3. This will be 5x now equal to 42. Then dividing both sides by 5 leaves us with x equals 8.4. So in order to serve 14 people, we should use 8.4 cups of the ingredient. With that, we have discussed the basics of ratios and proportions, which we will be making use of in our next couple of videos. Until then,